at example 5 now. Page 155. Okay, page 155. A particle moves in a straight line with velocity v meters per second, where v is this, and t is the time in seconds after passing through a fixed point O. That means I will have a fixed point O, and the particle passes through with v equals to 20e minus t over 4. Am I right? Okay? Find the initial acceleration of the particle. Now, part 1. We know that v is this. If I want to find acceleration, it will be the differentiation of the velocity. Am I right to say that? So I will have 20 e minus t over 4 times negative 1/4. Okay? I differentiate the top. So this will be a negative 5e minus t over 4. Everybody clear? Yes or no? Okay, the question asks for what is the initial acceleration of the particle? Now, initial acceleration means when t equals to 0, right? Okay, so when t equals to 0, acceleration will be negative 5. Now, this is e to the power of 0. E to the power of 0 is what? 1. So this will be negative 5 meter per second squared. Because the question is meter and then seconds. Negative 5 meter per second square. Are we okay? Can, okay, next part. The displacement of the particle from O when t is 4. When t is 4. Okay. Now, velocity is this. If I want to get displacement, I must integrate. I must integrate velocity. Okay, so this will give me a 20 e minus t over 4, 1 over negative 1 over 4. Correct. So what does this give me? Negative 80 e minus t over 4 plus what? I must plus c because it's a indefinite integral. Okay? Alright. Now, find the displacement of the particle from O when t is 4. Now, I must first of all find out the value of t first. Do you agree that when t is 0, s is 0, according to the question? Because you start timing from there. Okay? So, I will have 0 equals to negative 80e0 plus c. So 0 is negative 80 plus c. So what is c? C is 80, Can you see what I'm talking about? So the displacement will be negative 80e v plus. Okay? What if t is equals to 4? I will have negative 1 like this. Negative 1, right? 4 over 4 is 1. Then plus 80, correct? Okay, all of you key in your calculator. What's the displacement when t equals to 4? 5 truncate first. 50.565. That means it's 569. So it's 50.6 meters, am I right? Yes or no class? Can you see this is exactly the same as the algebra one? Just that now we have the e function, that's all. Everybody clear? The format, everything is still the same. Okay? Alright, so that is for example 5. Are we okay with that? Are we okay with that? Okay, then we'll move on to example 6 now. Example 6 looks terrifying, but actually it's not. It's just some notation that you need to take care of. Okay? Can you read through it first while I clean the board? Are we ready? Okay, good. A particle P moves along a horizontal line so that t seconds after motion has begun. Its displacement SP meters from a fixed point O is given by this. That means this is the displacement function of P. Okay? Yeah, displacement function of T. Okay, next, part 1. Find an expression for the velocity of P in terms of T. They want the velocity. So actually, they want the velocity of P. Correct, class? So this is actually the SP over the T, right? Okay, class. So I will have what? 3t squared plus 14t minus 2. That's all. Do you agree this is the velocity function? Yes or no? Yes, huh? Okay, good. No, plus C or not? Why no need? It's differentiation. Very good. Okay, next, part 2. A second particle Q starts its motion at the same time as P and moves along the same horizontal line as P. Its acceleration, AQ, meter per second square, t second after motion has begun, is given by this here. AQ, this is part 1, huh? AQ is given by what? 6t plus 4. Okay? Given that Q has a velocity of 2 when t is 1 and an initial displacement of -1 meter, obtain expressions for the velocity and displacement of Q in terms of t. This one is just trying to confuse you, don't worry. Okay? First of all, we go and find the velocity first. From acceleration to velocity, I integrate this direct. So this will be what? Correct? That means VQ must be 3t squared plus 4t plus c. Okay? Now what's my aim here? To find what? Find C. Okay, now look at the question again. Okay? The velocity is 2 when t is 1, right? The question say one, not I say one. The question say that given that Q has a velocity of 2 when t is 1, that means okay. So I plug in. Can you see C is -5? Everybody okay? So what is the velocity function? 3t squared plus 4t minus 5. This is the velocity function. Everybody okay here? Can or cannot? Okay, then what do they ask for? The displacement function, right? Displacement function will be what? SQ, I have to integrate plus dx. Okay, don't go and do this one. This one is just t cubed plus 2t squared minus 5t plus d. Everybody okay? What is my job now? Find out what is what? D. Okay, let's take a look at the question now. An initial displacement, okay, of -1. Okay? Look at the question again. A second particle Q starts its motion the same time as P and moves along the same horizontal line as P. T seconds after motion. Now, initial displacement is -1. So, do you agree that when T is 0, SQ is -1? The question says what? Oh? So I plug in 0, 0, 0. So -1 is equal to B, right? Okay, so what is my displacement function? T cubed plus 2t squared minus 5t minus 1. So this is my displacement function. Everybody clear here? Okay, now last part. Okay, not last part, third part. Find the value of t at the instant when P and Q collide. Find the value of t at the instant when P and Q collide. Now, if they collide, right, they start from the point O. Did they say they start from the point O? Let me read again. Oh, they didn't, from a fixed point O. That means the displacement from O must be the same, right? That means if they collide at this place, the displacement for S and Q must be the same from here, right? Or even if they collide behind, it must be the same, right? Okay, for them to collide, SP must be equal to SQ. Agree? I'm not talking about distance though, I'm talking about displacement. Displacement must be the same. That means the distance from O must be the same. Okay? So I will have a T cubed plus 7T squared minus 2T minus 3 must be equals to T cubed plus 2T squared minus 5T minus 1, right? Okay, now I'm going to do this 5T squared plus 3T minus 2 equals to 0. Am I right to say that? So, what can I do here? I do the cross method, right? Okay, so 5T and T. So 2 and 1, I'm going to get plus 3. Rubbish, it should be 1. 2 and 1, right? 5T minus 2. So I'll get plus 3, correct? Agree, class? So I will have a 5T minus 2, T plus 1 equals to 0. Agree, class? So this one will be what? T equals to 2 over 5 or T equals to negative 1. Now, can T be negative? No. So this one is rejected. So what is the time? 2 seconds, right? Okay, find the value of T at which they collide. So they only want the value of T, so it's just 2 Everybody okay? Yes or no? Okay, good. Part 4. Are P and Q moving in the same direction when they collide? Remember, I said V positive means move this direction, right? V negative means the other direction, right? Okay. Let's take a look at VP, yeah? Now, velocity of P is 3T squared plus 14T minus 2. Velocity of Q is, I cleaned off already, so I cannot remember. What is it? Just now I find the velocity of Q. 3T squared plus 4T minus 5, right? Just now it was like that, right? Is it correct? Hey, talking to you. Is this correct? Yes, huh? Okay. Now, when they collide, what is T? T is what? 2/5. Okay, all of you start in. When T is 2/5, what is VP? All of you start in VP. Positive or negative? This is a positive value, right? Okay, what about VQ? Positive or negative? VQ. Positive or negative? Negative. Alright. So, what does this mean? Okay, I want you all now to turn back to page 147, all of you. Page 147. If V is bigger than 0, the particle moves the direction of the positive S-axis. Can you see it? Part C. If V is less than 0, the particle moves in the direction of the negative S-axis. Can you see it? Okay, so then let's answer this question. Are they moving in the same direction? Are they moving the same direction? No. Now, when will they be moving the same direction? When both are positive or when both are negative? Is that clear? Then they will move in the same direction. Are we clear with the explanation here? Yes or no? Okay, so that will be your example 6. Then I have given you 5 questions, right? I don't remember 4 or 5. 5 questions for you to do in your foolscap paper, correct? Okay, I will start now. Okay, those who have done, you just take it and see whether your presentation is correct. Okay, but I need to go through something about tomorrow first. Tomorrow you are going to have your WA2. Okay? Those who are absent without MC or whatever will be given 0 straight. We don't need to talk about it. Okay? And you know your position. Okay, I want you to move to your position for the test. Understand? Okay, the WA2 is on which chapters? 3, 4, and 5. The one on cumulative frequency, box physical diagram, percentile, whatever nonsense, then mean and SD. Okay, chapter 4 is on what? Matrices. What's chapter 5? Vectors. Okay, so these 3 go and revise yourself. Understand? Tomorrow straight away I come in, I'll administer the test. I don't wait. Don't say give me some time to revise. No need. If I give you so much time, a few minutes, it doesn't make a difference. Everybody clear? Okay? Alright, and one more thing. I gave you a PRWC question, right? And then I said I will go through it after, right? I will tell you when to bring, don't worry. I'll tell you when to bring because I need to go through the PRWC question. Understand? Remember the one that is like a heater, don't know what nonsense, a tank, and whether the foundation is required. Okay, so you bring it. You can just, it's just one piece of paper, just put it in your bag. Anytime I want to go through, I'll just go through. Will that be okay? Alright, good. Now, let's take a look at exercise 18.2. I'm starting off with number 3. Okay, I filled in your content page already for 18.2 years. Okay, let's start with number 3. All of you. Those who have done, of course, very good, thank you. Those who have not done, please take out your foolscap paper. We are going to do it now. Don't waste my time. Okay, let's look at question number 3. Alright. The question says, the acceleration a meters per second squared of a particle at time t seconds is given by a equals to -4 sine t. When t is 0, the velocity v of the particle is 4 meters per second and the displacement s of the particle is 7 meters. Find 1. The velocity of the particle at time t. Okay. So let's write down first. This is what is given, right? A is -4 sine t, right? Okay. Then the question says, is this correct? When t is 0, v is 4 and s is 7. Is it correct? Okay, now what did the first question ask us to find? The velocity of the particle at time t. Now, in order to find out the velocity, I need to integrate. When I integrate, I'll get -4, right? Correct. When I integrate sine, what do I get? Negative cosine. Cosine t plus c, right? What's my next step? Find what? Find c. Okay. When t is 0, v is 4. So 4 equals to 4 cosine 0 plus c. Now, a lot of you will make this mistake. they think cosine 0 is 0. It's not 0. Cosine 0 is 1. Okay, so this will give me C as 0, correct? Alright, because 4 minus 4 ma. So my velocity will be 4 cosine t. Everybody okay here? Okay, part 2. The displacement of the particle at time t. Okay, displacement will be integration of this, right? So I will have 4. This will become what? Sine t plus t, right? Plus t plus what? Plus d, right? Okay, then when t is 0, f is 7. The question say what? So 7 equals to 4 sine 0 plus d. Now sine 0 is really 0. Okay, so my d is actually equals to 7. So my displacement function is 4 sine t plus 7. Is everybody clear here? Is everybody clear here for these two functions? Yes or no? Okay, good. Now, next, part 3. The greatest velocity of the particle. Now, I need to move back to what you already know. Plus, if y is equal to something, right? dx equals to something, right? Okay? When is y the maximum? When dy dx is what? 0, right? It's either maximum or minimum. Then I got to show that d2y dx squared, if it's maximum, it has got to be less than 0, right? Then it will prove, right? Okay. Now, v, they want it to be the greatest. Okay, so what must be 0? The acceleration, right? Do you agree? V has got to be the greatest. So, dv dt must be 0, right? Which means acceleration must be 0. Agree, class? Okay. Now, when is acceleration 0? When negative 4 sine t is equals to 0. Okay? I will have sine t equals to 0. Am I right to say that? Now, when it's equal to 0, there's no need to do alpha. Can you see that it's a cycle? When 0, it will be 0, pi, and what? 2 pi, right? Is that clear? Is that clear to what I'm saying here? So, I will have t as 0, pi, 2 pi, etc. Am I right to say that? Okay, depending it will go on. Correct? Okay? Alright. Now, so what will happen here? Now, the question when it started, it already said when t is 0, v is 4 already. Correct? Yes or no? They already say that when t is 0, which is also here, velocity is 4, right? Okay, all of you look here. V is 4. Okay? Now, we know that the velocity function is what? Let me write this again. Velocity function is 4 cosine t. Am I right? Am I right to say that? Okay. So, what is dv dt? sorry, v dt, what is it? Something is wrong with my presentation. Let me just think about it first. Something is wrong with my presentation. Wait now. Something is wrong with my presentation. Wait now. I'm a bit confused here. Let me think first. When t is 0, okay? When t is 0, v is 4. That's right. I must see if this v is the maximum or not, right? Correct or not? Okay? So, in order to see whether it's a maximum or not, I'm going to do what? d2v dt squared. I'm talking to you. Are we clear? Are we clear? Okay. So, v is wait. Something is wrong here. I think something wrong here. Did I do something wrong here? When v is greater, dv dt is 0, so t is this, okay? I'm going to find d2v dt squared. Agree or not, class? Okay. Good. I didn't really understand that. So I'm going to find d2v dt squared. So what will d2v dt squared give me? Something here. This one's a bit confusing, right? This one's a bit confusing, right? Hey, I'm talking to you. Are you okay now? Okay, I explain again. It's a bit confusing. Hello? 再来一次, okay? I'm very stressed now. Not stressed, I'm very tired. I go from here. If y is something, v1 gets to 0 means either it's a maximum or I'm going to say that it's less than 0 in order to be maximum, right? Okay. So v is we want it to be the greatest, okay? V want it to be the greatest. So dv dt must be 0, right? That means a must be 0. So I found out t must be 0 or pi or whatever. Everybody okay? Now, okay, wait. Do you agree that acceleration is dv dt? Okay. So this is a negative 4 sine t, right? According to the question. What is d2v dt squared? I will have to differentiate this one, right? So it's negative 4 cosine t, right? So when t is 0, d2v dt squared will be not 0, because it will be what? Negative 4, right? Correct, because cosine 0 is 1 now, so it's negative 4. So this is less than 0, right? Can or cannot? So therefore, the question asks for what is the greatest velocity of the particle? So greatest velocity will be 4 meters per second. Are we clear now? I try to make it clear. Are we okay? Do you understand what I'm saying here? Can or cannot? Can or cannot? Can, okay, I want to take a look at this again so that I can carry on with the next question. Okay? This is your question 3. Can? Now, then some people will ask me, Joe, how would you know? How come you didn't take the others, right? Alright, to see if it's maximum or minimum, how come you take 0, right? Okay, now can we take a look at pi? This one is a copy, I just want to explain to you. Can we take a look at pi? Okay, now, when t is pi, v will be what? 4 cosine pi, which will become what? 4, right? What's that? 笑了。Wait, let me do the cosine function first. This is pi over 2 to pi over 2 pi. Wait. Pi over 2. Make a mistake again. 0 pi over 2. You look so funny. This is pi, right? Where's pi? Pi is here, right? Correct now? Okay. When it is pi, what is this value? Negative 1, right? Okay, so this will be a negative 4. Can you see? When t is pi, it's negative 4, right? Okay, I'm talking to you. Do you understand what I'm talking about? Okay. Repeat. For those who cannot, I'm going to repeat again now. Don't see this one already. We know that v is 4 cosine t. So when t is pi, v will be 4 cosine pi, right? This will be 4, and this is negative 1, right? Cosine pi is negative 1. Remember just now I draw this? This is pi. So it's negative 1. Okay? So this will be a negative 4, right? Everybody okay? Alright. Now, you want v to be the greatest. That means acceleration got to be 0. That means I'm taking pi. Correct? So acceleration is actually negative 4 sine t. So this is actually dv dt, correct now? Okay? What is the 2v dt squared? Just now I said it's negative 4 cosine t, right? So this is a negative 4. Now, cosine pi is negative 1, right? What's negative 1 and negative 4? It's 4. This is bigger than 0. Right? Bigger than 0 means what? This is actually a minimum. So you cannot take this one. Do you understand? That's why we must take this one. Everybody clear? I explained this in my video, but I want to explain it now to you. Like, everybody clear? Yes?
I think the value of 2 pi.
They want the first one actually. Okay? So you don't have to go until 2 pi. Okay? Understand? If they say the value of that beyond pi, then it's give me 2 pi.
So in this case,
Don't give me 2 pi. Okay? Everybody can? Everybody can? Okay? Okay. Actually, it's quite valid. What if you give 2 pi? Let me just think about it, okay? This is question 3, right? When acceleration is 0. What's my acceleration function now? When this is 0. 2 pi is still 0. Yes. Okay. If you want to give 2 pi, maybe you can say, the question may ask you like, other than when t goes to 0. So what's the first value? You just give me 2 pi. Okay? If not, you give me pi, it's 0 is okay with me. Okay? Alright, Okay. Alright. Next question. Are we almost done already? Not yet, Next question is question 6. Okay. I think I'm going to be stressed now. You look very tired. Question 6 or question 5?
5 then 6.
Oh, 5 then 6. Oh my goodness. Okay, forget to see the 5. Okay, now, you listen. This set of work is not due tomorrow, I say already. This first set of work is due when? Wednesday. You can look at the video. I did explain everything in the video. Do you understand? Can or cannot? Can or cannot? Okay, so you just take a look at that. Okay, I know how to explain to you. Valerie, if you take 2 pi, right, you also take 4 pi and 6 pi. Then you take so many, it's made one made, you know what I'm saying? So you take the first one. You understand what I'm talking about? You be the safest. Because if not, there will be a lot. You get what I'm talking about?
Generally, just take the first.
Take the first one.
Unless
they either specify or they ask you for certain. They'll be very specific in the question you want to do. Okay?
Thank you.
Okay, Alright, stop the video.